Hello, honors geometry students. Welcome to today's notes. Today we are going to be learning about the midpoint and the distance formula. We are still in target 2 right now, and so we're talking about line segments. And again, today we're going to focus on midpoint and distance formula. All right, so before we jump into the distance formula, let's first talk about the Pythagorean theorem, because this is actually where the distance formula comes from. The Pythagorean theorem, remember, is it's something we use with right triangles. So again, we have a right triangle here. What we do is we name all 3 sides. We call these sides on that make the right angle here A, and this one B, and then one across from the right angle, we call that one C. Now A and B, the 2 sides that make the right angle, those are called the legs. Okay, where this C is called the hypotenuse. And the Pythagorean theorem works that if I take the 2 legs, A and B, A squared plus B squared, it's going to equal C squared. All right, so go ahead and write down, so pause the video and write down this formula. Again, on the grid over there, I just kind of picked 2 random points. I don't really pay attention too much to exactly where A is and exactly where B is. I just want to kind of pick 2 arbitrary points. So remember, guys, for each one of these points, they each have an x coordinate and a y coordinate. I've called the points for A, x1 and y1, while I've called the ones for point B, x2 and y2. So when I plug these into my formula, all right, the distance equals the square root of x2 minus x1. So again, this one right here is x2 minus x1 right there, and then we're going to square that. And then do the same thing with the y's. I go y2, which is this one right here, minus y1, which is this one right here, and I'm going to square that as well. Go ahead and do that, and then you're going to take the square root of the whole thing, and that'll give you the distance between those 2 points. All right, so like I said, the Pythagorean theorem is kind of where all this stuff comes from. And what I mean, I'm going to show you what exactly that means here. So go ahead and plot the points RT. If you need to pause the video, that's fine. Plot R and T. R is -1, where T is the point 3, 2. So the first things first, I want to use the Pythagorean theorem to find the distance from R to T. Now you might be thinking, well, I don't have a right triangle. How exactly am I going to do the Pythagorean theorem? So the problem with doing distance from R to T is that it spans across diagonally here. All right, so I don't know exactly what this space is going to be between these 2 parts. So what I can do here is I can actually draw in a vertical line from R to right about there, and then a horizontal line over here to T. And you notice as soon as I do this, I have myself a right triangle. Not only do I have a right triangle, but I can tell you exactly how long each one of these 2 sides are, because they are vertical and horizontal lines. All right, so we'll call this point S, just to kind of give it a name. If I want to go from R to S here, again, we know that's a right angle right there because it's a vertical and a horizontal line intersection. And if I count from R to S, I go 1, 2, 3 units from R to S. Again, guys, don't count. When I count, don't count where you start, okay? It's the distance. So from here to here is 1, there's 2, there's 3. Same thing as I go from S to T, there's 1, there's 2, there's 3, there's 4. So the length of ST is going to be 4. Now, I don't know what RT is, so I'll go ahead and call that X. You can call it C, you can call it whatever you want to. Again, this is a Pythagorean theorem problem. So it's leg squared plus leg squared. 3 and 4 are my legs. So 3 squared plus 4 squared is going to equal my hypotenuse, which is x squared. 3 squared is 9, 4 squared is 16. If I add those 2 together, I get 25. Last but not least, I'm going to square root, and x is going to be equal to 5. Okay, so the length of RT is equal to 5. And again, when we talk about the length of a segment, we use just the 2 letters R and T, no line over the top of it. RT equals 5. So that's how you use the Pythagorean theorem to find the distance between 2 points. Now again, we could also use this distance formula that we talked about. Distance formula will also give me the exact same answer. So I'm just going to rewrite the formula for us. We've got D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, what we need to do here is we need to figure out which point is which, okay? And so I'm going to go ahead and label my points here real quick. We've got R is the point -1, -1. And then T is the point 3, 2. Now, and again, I'll just kind of write them on the side over here. R, -1, -1. And then T is the point 3, 2. Now, we need to decide which one of these is going to be 0.1 and which one of these is going to be 0.2. And here's the deal. It really doesn't matter which one's which. As long as you're consistent with your x's and your y's, it doesn't really make a difference which one is 0.1 and which one is 0.2. I'm just going to call R point number 1, and I'm going to call T point number 2. All right? So when I start off doing this, I'm going to take my x's, which are -1 and 3, and I'm going to plug those into my formula. Okay, so again, D equals, it's the square root of x2 minus x1. All right, so again, x2 is going to be this number right here, which is going to be 3. That's the x-coordinate of point number 2. So 3 is going to go first, minus the x-coordinate from point number 1, which is going to be -1. So minus -1, and then we're going to square that. Now remember, when I have two negatives in a row like I have here, two negatives in a row make a positive, so I'm going to go ahead and make that change right there. And then I'm going to keep going with this. We've got y2 minus y1, so y2 is going to be this one right here. That's the y-coordinate of point number 2. So I'm going to go plus y2, which is 2. And then I'm going to go minus y1, which again is going to be -1 squared. And again, I've got that plus positive in a row right there, so make sure we let that reflect. All right, next step is going to be, we're going to do some simplifying. All right, so right here I've got 3 plus 1. 3 plus 1 is going to be 4. 4 squared is going to be 16. All right, right here I've got 2 plus 1. 2 plus 1 is 3. 3 squared is going to be 9. 16 and 9 is going to make 25, and we know the square root of 25 is going to be 5. So again, I get RT, which is my segment. Remember, don't put a line on top of it, just the R and the T equals 5, and that is the exact same thing we got on the opposite side of the page. Now, both of these are perfectly fine ways to solve this. It's up to you how you want to do it, if you want to use distance formula or Pythagorean theorem. Now, the reason we do both is the Pythagorean theorem only really works if you have a coordinate grid like I have right here. If I don't have a coordinate grid and I just give you 2 points, you're going to have to use the distance formula. So I'd be able to do both. All right, so go ahead, and I want you guys to try this one on your own. At least plug it into the formula. Pause the video right now, okay, and plug this into the formula. Make sure we're plugging it in correctly, and then we'll come back together in a minute. All right, so I am finding the distance between these 2 points. I have decided that I'm going to call R right here 0.1, and I'm going to call S 0.2. All right, so when I plug this in, I'm going to go x2 minus x1, so 4 minus 2 squared plus -1 minus 3 squared. Now here's the deal. If you instead wrote down this 2 minus 4 squared plus -3 minus -1 squared, that's totally fine. If you switch it up and you called S point number 1, you called R point number 2, that's totally fine. You're going to get the exact same thing, and I'm going to show you you're going to get the exact same thing. All right, so up here again, I'm going to simplify. 4 minus 2 is 2. Squared is going to be 4. And then right here, I got -1 minus 3, which is -4. -4 squared is going to be positive 16. Be careful when you plug this into your calculator, okay? Make sure you put parentheses around your -4. -4 times -4 is positive 16, not -16. All right, and I get 4 plus 16, which is going to be the square root of 20. We're going to leave that right there for a second, and I'm going to show you again how the purple one's going to work out to be the exact same thing. All right, so underneath here, 2 minus 4 is -2. -2 squared is going to be positive 4. And then right here, I go -3 minus -1. Remember, that's going to be plus a positive 1. Okay. So there is positive 3. Just kidding, sorry. To be positive 3 plus 1. So I get 3 plus 1 is going to be 4. 4 squared is 16. 4 plus 16 is going to be 20. And as you can see, right here and right here, these two things are identical. So it doesn't matter what order you put it in, you're going to get the exact same answer either way. All right, now last but not least, the reason why I left it right here is because we need to finish this problem, okay? And I finished this problem by simplifying the radical. I want to give an exact answer. So 2 goes into 20 10 times, and then 2 goes into 10 5 times. Remember, what we're looking for is a pair, so the pair gets to come out. So 2 comes out, and then that 5 stays inside the radical. And I'm left with RS is equal to 2 root 5. All right, on the very next page, you've got a little bit of an activity. Now, I'd like you to try to go through this activity on your own, okay? I'm going to kind of walk you through number 1 and number 3, and then I want you to try the other ones on your own, and I really, really want you to try to come up with this midpoint formula all by yourself, okay? So, first of all, what is a midpoint? A midpoint is a point that is exactly in the middle of a line segment. It's going to be, exactly in the middle, which means the distance from each side is going to be identical. So here's A, here's B. The midpoint is going to be halfway in between point A and point B. So what does that look like, particularly in this segment? Well, I've got a horizontal segment, okay? And again, we can kind of count the distance from A to B here. So from A to B, that's 1 unit. There's 2 units, 3 units, 4 units, 5 units, 6 units. So this whole line segment is 6 units long. Okay, well, if it's 6 units long, that means the midpoint is going to be halfway. So it's going to be 3 points. So if I go from A to B, 1, 2, 3 is going to be this point right here. So let's go ahead and draw that in. And I'm going to call that point M for midpoint. All right, and again, that point is going to be, my x-coordinate is 3, and my y-coordinate is going to be 4. Okay, so looking at my 2 points, I have 0, 4, and 6, 4. The midpoint is exactly halfway at 3, 4. All right, now number 2 is a vertical line, so very similar. So go ahead and pause this, try that one on your own, and try to find the midpoint of CD. All right, for this one, we should have gotten -3 as my x-coordinate, and then my y-coordinate should have been -1. Halfway between 5 and -7. So -3, -1. Sorry, over here, 3 and +4. All right, the vertical and horizontal lines are a little bit easier because I can just kind of see exactly where that halfway point is going to be. So let's take a look at one of these diagonal lines. All right, so EF is 2, 2, and 8, 8. All right, so 2, 2, and 8, 8. Again, we want to try to figure out exactly where the halfway point's going to be. So I'm looking at this line, and I'm kind of saying, well, where exactly about is halfway? And it looks to be right around this point right here. Okay, if you're kind of using like slopes and rise and run, it goes up 1, 2, 3 over 1, 2, 3. Up 1, 2, 3 over 1, 2, 3. That's about exactly halfway. So I'm going to go ahead and throw this point right there, and that's going to be my M. Well, what are the coordinates of M? Okay, so if I count my x-coordinates, it's going to be, it looks like it's going to be 6. All right, and if I look at my y-coordinates, that's also going to be 6. Oh, just kidding, 5 and 5. Sorry, 5 and 5. So again, looking at my numbers here, I've got 2, 2, and I've got 8, 8. Okay, 2 and 8, okay, are, they're 6 units apart from each other. And so that halfway point is going to be 3 units apart from each other. So how am I getting to this midpoint based on that? All right, go ahead and try these last few problems. Okay, try to find these midpoints, again, on your own, and then see if you can kind of observe a pattern between the points that you're given and the actual midpoint. All right, for number 4, we should have gotten 1, -1 for that midpoint. For number 5, we should have gotten -1.5 and -1. And for number 6, I should have gotten -8 and 6. Now, number 6 is a little bit tough because it goes off the grid, but here's the deal. It's the last problem for a reason. At this point, you should have developed some sort of formula to understand, hey, how do I get this midpoint? How can I do this without counting stuff on the graph? All right, and that formula is the midpoint equals x1 plus x2 divided by 2. That's going to give you your x-coordinate. y1 plus y2 divided by 2. that's going to give you your y coordinate. Think of this as an average. Okay, the average x coordinate and the average y coordinate. If I have two x's on a line segment, x plus x divided by 2 gives me that average. It gives me exactly the halfway point. Same thing with the y's. Y plus y divided by 2 gives me the exact midpoint right there. All right. All right. So go ahead and try these try now problems on your own. If you have questions, please come to office hours, and I hope you guys have a good day.